Good afternoon, my YouTube viewers. Crystal here. What I wanted to do this afternoon is I wanted to go over a program with you and do a code review because I actually started the program yesterday and I made the video for you yesterday afternoon using Facebook Profit. But what I wanted to do was I wanted to add append to this program stats models because I wanted to see if stats models was a more suitable option to predicting upon the COVID-19 time series than Facebook Profit was. And the reason why is because on Facebook Profit I got a relatively high score on my RMSE, and I thought, well, maybe stats models will do better. Maybe I'll get a better score with stats models. So I tried to put some stats models functions into the program just to see which was better, Facebook Profit or stats models. So what I'm going to do now is we're going to do a code review, and I'm going to show you which one is better. I'm going to show you the different models that we use, the RMSEs, and which one is better, based on Facebook or stats models, or you can decide for yourself which one is better really. So the first thing I did was as you can see, we've got a problem here. The first thing I did was I downloaded the CSV file from this website called ourworldindata.org for the coronavirus source data. Now this website or this CSV file is updated every day. So every day that you work on this CSV file, you have to reload it. So basically, I had downloaded it into my downloads, so I had to delete it from my downloads. And then I had to today, which is Christmas Day actually, I had to download it again a second time, and then I had to copy it in my Google Drive, and then I got a message saying that it was going to copy over the existing CSV file. And the reason for that is because every day this CSV file is added to, and because it's added to every day, you want to make sure that you're working with the most current data. So yesterday I downloaded the CSV file and I was using it, and this morning I downloaded a new CSV file. So we're using the most current data that we have, which is good, and I wanted to let you know that. So I downloaded the CSV file. You've got to do it every day because the CSV file is updated every day. I wrote my program on Google Colab because Google Colab is an online Jupyter notebook. It's got a lot of the libraries already installed on it, and because it has a lot of the libraries already installed, all you have to do is import the libraries. In addition to that, because it's online, you can go to any computer where you have internet access and can get Google and use Google Colab, because there's one place that I have to be 4 days a week, and I have access to a computer, so I can go onto that computer and call up Google and call up my program on that computer. So that's why I use Google Colab. It's a very good program. You know, I had toyed with the idea of saving these data sets onto my own hard drive, but it was very difficult for me to do it because I think what they were saying is that you have to have your Jupyter notebook on the same drive that you've got the data sets on. And then if I did that, then that meant then I would not be able to go place to place and just turn on any computer and work on my file. So in the end, I decided just to stick with my Google Drive and my Google Colab. So I'm not storing a great deal of information on my hard drive of my computer, except for my blog posts. My blog posts are being stored on the hard drive of my computer. So after I loaded up my pandas and my NumPy, I decided to read the file. So that file is actually stored on my Google Drive. So you're going to need to store it on your Google Drive. But from what I understand, there is a GitHub account that you can use where the files are updated every day. But I just decided I'll stick with what I've got. I'll just stick with this program, this website, and I'll stick with what I've got. But if you want to use that GitHub account where the CSV file of COVID-19 is updated every day, well, that's entirely up to you. So I read my train file. We've only got one data set. So it's very long. It's a very big file. It is composed of lots of different countries. And so what I did was I did some info on the train file. And as you can see, this particular file has a total of 52 columns. So it's got a lot of information on it. But I decided that what I wanted to do was just wanted to work on the UK. I didn't want to work on other countries. I'm living in the UK, so UK is what I'm interested in. So what I did was I filtered out all of the data relating to UK. So that's what I did. I filtered it out. So you can see this is our filter. And so what I did was I created a new data frame, called it UK New Case, and it's got index, date, and new cases on it. And so I had to rename the columns because what Facebook Profit wants is Facebook Profit wants like the date time to be called DS and the Y and the actual target variable to be called Y. So we had to rename the columns to something that Facebook wants to see. We've got a graph of our time series for COVID. So you can see they began taking records, I believe. Let's see when they actually began taking records. 131, it looks like their first records was January 31st, 2020. So they began taking records approximately 11 months ago. So the first record is January 31st, 2020. So you can see that it had from January 31st, 2020, it started out low and then it had a bit of a peak. And when it had the peak, that's when we went into lockdown the first time. That was around March. So we went into lockdown the first time around March. And then they said that we could go back to normal. And then so it lied low for a little while. And now it's peaked again. The reason why it has peaked again, one of the reasons why it's peaked again in the UK is because apparently there's a new variant of this virus and it has come out of London. Because it has come out of London, we're in tier 4. Where I live, I'm in tier 4, so that's just basically lockdown. Most everything is closed. And what they've done is they have a travel ban now. They don't want people to leave the UK, and other countries don't want people from the UK going into their country because this new strain of this virus is a lot more contagious than the previous strain. So it's mutated. And at the moment, at the time of this video, we've got 3 mutations that I'm aware of. We've got the mutation that's come out of London, and I live about 45 miles away from London. We've got a mutation from South Africa, and then there's another mutation from another African country as well. I'm not sure exactly what African country it is, so I won't say, but I think it's North African country. So I don't want to say what country it is because I'm not sure. And but so far we've got 3 strains of the original virus. The strain out of London is much more contagious than the other strains. So now what we've done is we split our time series. So we got our month equals January 2021. So that's our time series. So what we've done is we've created a new data set. We've created a test data set. And so basically it's for this test data set, it's for the entire month of January 2021. So the only thing that it's got is the dates in it. It doesn't have any target variables or dependent variables in it, because that's what we are going to have to predict upon. And then with this new data set that we have created, what we have to do is we have to rename the columns to something that Facebook Profit wants to see. So we renamed the date column to be DS. And now we get to the actual part of splitting our data. Xtrain equals UK new case dot log, UK new case DS, and if it's less than December 1st, 2020, Xval is UK new case dot log, UK DS, if it's greater than or equal to 1st December 2020. And Xtest, that's the data frame that we made, is test.log test DS if it's greater than or equal to January 1st, 2021. So now we've got FB profit. So model equals profit, model.fit equals Xtrain. So now what we're going to do is we're going to predict on the validation set. So we have predicted on the validation set, and the validation set at this time is 24 days because the CSV file was updated yesterday with the information from yesterday. And what we want to know specifically is Y hat. That's what we're looking for. So Y hat is really Y with this little upside down V on the top of it. And that's why they call it Y hat, because it looks like it has a hat on it. And that's what we're looking for, is Y hat. Now we check our RMSE, that's root mean squared error. That's a specific way to test for errors in your predictions. And RMSE was 8445. And so yesterday I was thinking to myself, well, gee, 8445, that's a lot. And I was just wondering if I could get a better prediction if I use statsmodels. So that's what I did. I appended statsmodels functions to this program because I wanted to see if I would get a lower RMSE with statsmodels. So that's what we're going to discuss. I'm going to show you, and we're going to see whether statsmodels is a better library to use than FB Profit. So we forecasted on FB Profit, and then we put it on a data frame, and you can compare our actual values against our predicted values. And then so basically we put it on a chart. So what we've done is we've done that. I mean, all of these charts came up on Google Colab, but for some reason, I'm not sure exactly why they didn't come up on GitHub, but that's not really that important because the main chart has come up. The main chart has come up where you can see where in February 2020, we had all of these coronavirus cases, and then what we did was we had a spike, and then when we had the spike, that's when we had the first lockdown, and then it went down again, and then it went up again. In November 2020, we had another lockdown. So November 2020, we had another lockdown, and now they decided that we were going to have a 3-tier system. Well, I live in Reading, so Reading was tier 3, but now they've decided they're going to have an additional tier called a 4-tier system, and this now I'm in tier 4. So that's really ruined a lot of people's Christmases. It didn't ruin my Christmas that much, so much, because I'm here with my boyfriend, but I know my boyfriend's really upset because he wanted to see his mother for Christmas and he didn't get to. So you can see how this data science actually affects our day-to-day lives, because I'm using data science to predict upon a real life problem. So we'll go back down, and you can see the blue here is the validation set, where it says it's going to be increasingly going up. So we got, and now what we're going to do is we're going to predict on the test set. The test set is that set that we created. And you can see here we got our Y hat on our test set. So that's what we're looking for, really, is the Y hat. And we prepare our prediction, and anything less than 0 is automatically a 0. And we put it on a data frame, and if this was a competition question, then we would be able to say, well, yeah, this is my data frame, because we've got our date and we've got our new cases. And so this file is called P new cases. That means it's profit new cases. And then so what I decided to do was I decided to go ahead and make some charts of what we have predicted, so you can see our prediction graphically. So we made a data frame where we appended prediction, which was X test, to forecast, which was X val. And I'm trying to find that for you. And we come over here and we've got our X test, we've got our Y hat, which is X test and X val. So you can see that we've got Y hat, so you've got forecast, which was your X val, and we have appended prediction to it, which was your X test. So now you can see a graphical representation of that. The graphical representation shows the X train, the X val, and the X test, and you can see the figures increasingly going up. And here's some more charts if you like charts. So what I decided was, I was just thinking to myself, well, I'm not really happy about this. I thought, I wonder if stats models will do a better job. So now what I've done is I've appended stats models to the program, so you can see for yourself if stats models would do a better job than Facebook Profit. So we've got our naive approach. And so you can see that the naive approach is just a straight line. It doesn't go up. It's just a straight line. And as you can see here, the yellow here is our validation set. And you can see because a few days before Christmas, they said that we're going into tier 4 and we have to stay home. So you can see here that, you know, at the beginning of the period, we had a few cases, and then the cases jumped up, so we went into the first lockdown. We finished the first lockdown, and then it subsided a bit, and then we've got this new strain of this virus. And so, because we had the new strain of the virus, it's much more contagious than the old strain. It popped up again, so we had a second lockdown that lasted a month. And then they let us go out of lockdown. And now they find out, now we've got three strains of this, 3 mutations of this original virus. And you can see that the cases are just going up. I mean, and so Nave isn't picking that up. Nave is just a straight line. So you can see your white hat. You can see your nave. It's just coming down as a straight line. You can see your RMSC, which is what we're looking at, is 13,999. That is higher than Facebook profit. Let me just see what Facebook profit is. Facebook profit is 8,445. So nave isn't any good. And then we tried auto regression. So we tried this auto regression model. We put it on a data frame so you can compare the predicted values against the actual values. And then you can see it's a line that goes down the negative way. And so if it's going negative, that's not any good, is it? And so you've got an RMSC of 17,889. Well, that's almost double Facebook profit. Then we've got something called moving average. Again, moving average is just a straight line. RMSC is 9158. So the RMSC it's not as bad as the previous RMSCs for stats model, but it's still not as good as Facebook profit because Facebook profit is 8,445. Then we've got ARMA, that's auto regression moving average. We put it on a data frame so you can compare your predicted values against your real values. We plotted it, and you see it's a straight line, but the straight line is sloping down. Looked at our RMSC, it's 13,792. That's still worse than Facebook profit. So the next thing we have is simple exponential smoothing. We put that on a data frame, and it's all just basically the same thing as 12,908. And again, you can see it's just a straight line. So we checked our RMSC on that, and it's 13,627. So you can see that that's a lot worse than Facebook profit. So now we're trying Holt's linear trend model, and we graph that, and that's a straight line, but it's going down. It's a straight line going down instead of going up. Our RMSC is 21,876. So, that's like 2.5 times worse than Facebook profit. Then we've got Holt-Winters exponential smoothing. We put that on a graph. It's just a straight line. And your RMSC is 12,594. So as you can see, we tried to use this stats models, and all of the models that we used on stats models performed more poorly than Facebook profit. So Facebook profit is a better model to use for COVID-19 data science projects. And because I didn't even try, because I'd been working on this all day long, Christmas Day, and so I didn't even try to make any predictions on the test set, because that would have taken me more time to predict on the test set. And if the RMSCs are that bad, then it's not even worth predicting on the test set, because you know that the predictions that you get are not going to be reliable. So I just stuck with FB profit. So this, I'm going to ask the question in my blog post is stats models a suitable library to use in predicting COVID-19 cases? And the answer is going to be no, it's not a suitable model, because we carried out all of the calculations and plotted on a graph so you can see for yourself, and Facebook Profit performed better than stats models. So that concludes my video. If you like my video, please like, subscribe, and share. If you like the work I do and you would like to leave a donation, I've got my email address to my PayPal account in the description box down below. The reason why is because I don't have enough subscribers to be able to monetize, which is why I have to ask for donations. So thank you so much for looking at this video and looking at the code review. And if you like it, please subscribe and tap the little bell button so you'll get all of my other videos. And thank you so much for watching this video, and I look forward to making new videos for you in the future.